Okay, let's see what we got here. Maximum number of words you can type. That's easy. There's a malfunctioning keyboard where some letter keys do not work. All other keys on the keyboard work properly. Given a string text of words separated by a single space, no leading or trailing spaces, and a string broken letters of all distinct letter key. And a string broken letters of all distinct letter keys that are broken, return the number of keys in the text you can properly. Number of words and text you can fully type using this keyboard. Given a string of words, separate. Okay, so given a bunch of words. No, not a bunch of words. 2 words with a space between them. And broken letters. Return the number of words in text you can fully type. Okay. So I think probably you just need to iterate over the letters, determine if any of the letters is in the other kind of set of broken letters, and then return the count. Okay. So I think it's, you could, if this was more complicated, like if there were n words in there, like a bunch of spaces, a bunch of different words between those spaces, you might want to use a split operator on, or split function call on the text, splitting at spaces, like text dot split open paren space close paren. But here, since there's only one, I think I'll not do that because it takes that's a then deal, and you can just do this in the past, I think. So I'll do 2 while loops, indexing through the spaces. Actually, I still need to, 2 while loops. So index is 0, while text at index, while text at index not equal to space, you'll need to increment, and if text at this index is, if that character is in the broken letters, then this is a word that cannot be typed. So answer, which is the count of the number of words that can't be typed, is incremented. We'll go ahead and break here. So this will stop the loop possibly earlier than the end of the word. So I'll go ahead and do a second while loop. So while this is not a space with this index increment, this is just going through. So this is early terminating. The reason why I'm doing this in two while loops is I want to only test. This is like a additional cost per loop, and I don't need to do this cost. This even checking the condition is a cost. So I don't want to do that cost if I already know that this word cannot be typed. So this, like, you go through the letters of the first word, checking each letter each time to see if the letters and the broken letters set of broken letters. And if you do find it before kind of finding the end of the word, then in the later letters you can skip the check. but you still need to find where the space is. You don't know where the space is. And then the second part would be just while text. Yeah, while text. While text at this index is less than n, where n is the length of this index, or length of this text. Here I just need to go all till it actually stops on this n condition. Okay, I think that's right. Oops. This should be the index. Index is less than n. Actually, I don't think I did the. Yes, I'm doing case 3 wrong. Huh. Oh, this should be answers 2 and then decremented by 1 each time. Oops. But I think my logic is still incorrect here. I think so. It stops when there's a space. I think I need another index plus equals 1 here. The index is at the space. Yeah. Okay. So answer is not the count of wrong answers, it's the count of the answers that can count of the words that can be typed. So it starts with 2 and then gets decremented by 1 for each word that cannot be typed. Oh, whoops. All text not equal to. I thought there was a guarantee that there was 2 words here. Oh, 1 word. Strengths. Text consists of words separated by a single space. String of words. Okay, there can be multiple words, I guess. Oh, I see. Oh, okay. In that case, maybe I do need to, I might just want to use split. Okay. Words is going to be text dot split spaces. Just double checking here. Yeah. Okay, so that really makes the actual just string of or array of words based on the text. And then I'll say for answers equal to the count of the words, number of words, or the number of things in that array. for every word in words. I wonder what the best way of actually checking to see if any letters in the thing appears within broken letters. I think it probably is something like for every letter in word, if the letter is in the broken letters, then answer minus equals 1 break. I think that's probably correct, or probably fast enough. Alright, cool beans. There might be other ways of doing that, but I think that's fine. Okay, so without the misunderstanding of what the hell I'm doing, so summary. Okay, so since there can be multiple words, probably the fastest or simplest way of making the input usable in Python is to use the split function on split function on string to break the text into word string chunks into an array of word string chunks. Then iterate over the words, where each iteration will check to see if any characters or any letters in the word appears in the broken letter. Now, previously I would have converted broken letters into a set and check to see if that thing appears in the set, but in a fairly recent example, I found that using n for letter n, just a string, is pretty fast. So, to do that, iterate over letters in the word, checking for that letter being in the broken string. Keep answer as a counter, starting with the assumption that no words are broken, and thus answer starts. Answer is initially equal to the number of words and decrementing when a letter appears broken. Breaking early. That loop. Yep. Time complexity. This is going to be O of n, where n is the number of letters in the text. As each letter will need to be checked in the worst case. Basically, if all words contain no broken letters, you need to figure that out, right? If it's if the only letter that was broken was Z and all the words don't contain Z, then I mean you'll need to eventually do this check for every single letter because there's no early exit. Base complexity, this can be O of n. O of n, yeah, as the to use a temporary array for the word chunks.